So today our group will be presenting about the real depth and apparent depth, which is a phenomena it originates from this refraction of light. So what is real depth? Real depth is the distance of the object at the bottom of the beaker to the surface of the liquid here. And then apparent depth is the image of the object you see from up here, which appears actually like shallower than the real object down here. So the real depth is taken from the pin.
Real depth?
The apparent depth is taken from the pin here, the position of the pin, to the surface of the water. This is the apparent depth of this object at the real depth of 16 centimeter. So what we did was we manipulated the real depth from a depth of 8 centimeter to 16 centimeter. So our group, so now this is at 16 centimeter. So how do we get the apparent depth? The thing is, we put a pin inside the water, and another pin is outside here, mounted to a cork. So when
the one that inside the water represent
the object. Yeah, the object. So when you look from up here, it is parallel. This pin is parallel to the pin inside the water. So how to get the apparent depth? The thing is, we have to look from up here, then we move backwards a bit, and make sure that the pin outside is in line with the pin inside, so it doesn't like change position. That means that is not the apparent depth. So when you move from here, you move to the middle, move to the back, the pin is always in line. So that is the apparent depth of the object at this real depth. So what we got was, if you plot a graph according to what we have here, it will be a graph of real depth against apparent depth. So what you will get is
real depth against
apparent depth.
Real depth against apparent. Which one is your manipulated variable?
Real depth.
Real
it's on the
depth.
y-axis.
So y-axis should be
real depth. Apparent.
Horizontal axis is the manipulated variable. Vertical axis is the responding variable. So you should plot graph of
apparent depth against real depth.
Apparent depth against real depth. Right then?
The result you will get will be a directly proportional graph. It shows that apparent depth increases with real depth. So the gradient of the graph is actually the refractive index of water. So the
gradient is constant, lah.
Yeah. So what is the refractive index of water? Refractive index of water is like how much does the light bend when it passes through the water? It's a constant number.
What if I should not ask, I let other people ask. Any question or not?
What if
What if you change the density?
What if you change the density?
So what we kept constant is the density of the water, because if you change the density of the water, like you use another kind of liquid, maybe oil, the refractive index will be lesser because it is optically less dense than water. That means that when light passes through it, it will bend
Less or more?
Less, I think. Yeah, it will bend lesser. So that's why we have to keep the density of the liquid constant. So we use only one type of liquid, which is water. Yeah. So at different real depths, like if we start from the bottom 8, this apparent depth will be like lower down here. That means that it is lesser than it was at this real depth of 16 centimeter. Yeah.
Okay, any question? Any question? Any question or not? Emily, any question?
Can you show how to manipulate the real depth?
So we just indicate here from like this one is 8, 10, 12, 14, 16.
By adding water?
Yeah, we add water. We started from 8 here. After that we increase the water to 10, then 12.
Oh, so it's... Oh, okay.
Yeah, this is the real depth lah.
I cannot see the pin line.
The pin is inside. You have to look from here. From here.